Okay, class, welcome to lecture 4. So today we're talking about the presentation of data. So the idea here is we can think of things more visually, which often helps people. Okay, so by showing data in a more visual way, what specifically can we do? We can estimate the center, aka the mean or the median, and the spread, how spread out the data is, with a quick glance. Okay, so what's one way to present data? So this is probably the most common way. It's using something called a histogram. You probably have seen these before. So it uses rectangles. So you get one rectangle for each, not for each data point, but for each data class. So what's a data class? This is just a grouping of the data points. So when we see an example, it'll be more clear. But you use a rectangle for each data class, where the height of each rectangle is determined by the number of things in that data class. So determined by the number of data points in the data class. So the more there are, the higher the rectangle will be. The less there are, the lower the rectangle will be. So for example, first I'm just going to draw a histogram without any real context. But typically what you do is you make these out of, first you have data. Okay, so down here, we're going to write the data classes. So this is saying that the data fits into it's either 6, 7, 8, 9, 10, or 11. Those are the data classes. And then on the left here is the frequency. So that means how many times each data class shows up. And so I'm going to count by twos here from 2 to 18, 2, 4, 6, 8, 10, 12, 14, 16, 18. So then at each data class, so for example at 6, I draw a rectangle, and its height is how many sixes there are. So I'm trying to make this go up to 7. That's kind of hard if you're crappy at drawing like me. So this is just like a little guideline, but it's not really part of the graph. So I'm going to erase it. Okay, so that should be at 7. Okay, and then the data point 7, I will make a rectangle going up to about 11. I don't know why I picked odd numbers that are in between, but whatever. So just to be extra clear, I'll put how many inside, but you don't usually do that. Okay, and then how many 8s will there be? Let's go all the way up to 18. Okay, so there's 18 of these 8s. How many 9s? There'll be, let's do 9 of those. So that's about there. For 10, we'll go down to 6. So that's about right there. And for 11, we'll go down to 3. So normally you wouldn't put these numbers in here, but it's just because I'm so bad at drawing that I need to clarify what the height of each rectangle is. Okay, so now let's say some stuff here. What's going on? So here, the data classes are like I said, 6, 7, 8, 9, 10, and 11. So there are 6 of them. And the histogram tells us what the data is. So what does it tell us? It tells us that there are there are 7 data points of value 6. That's what this first rectangle is saying, because it goes up to height 7. And it's in the data class 6. So there's 11 data points of value 7, 18 of value 8. There's 9 of value 9. And there's 6 of value 10. And 3 of value 11. So normally what you would do is you would have these first, and then you would make the histogram from this. But we sort of did it backwards just to see how histograms work. Okay. So what else does the histogram do for us? Well, you can sort of now very visually see that the middle of the data should be around 8, if not just 8 itself. And so we can estimate that. So that's one nice thing about histograms. Okay, so the histogram lets us estimate that the mean and also the median are probably around or exactly equal to 8. And the data is sort of a little bit spread. But even better, it is spread around this 8. So it's not too far. So most of the data is around 8. It's not super spread out. Okay. So in general, there are guidelines to making histograms, but they're not like set in stone. So I would call this a good histogram because it accurately displays the center and spread. So what you can do is you can do whatever you want. So you can make another histogram with the same data that sort of looks different and doesn't really show what's going on. So let's see, and that would be a bad histogram. So this is good because you can sort of just look at it and see like, okay, 8's the middle and everything is clustered nicely around 8, pretty even on both sides. And if I do something different, that won't happen. So let's see that. Okay, so we'll use the same data. To make a different histogram. So certain methods create bad histograms. So you'll see these a lot on like the internet when people want to misinform you. They'll use badly created histograms to try to trick you into seeing certain things. And so I guess they're really bad because, to be more specific, they hide the shape. They hide the shape of the data, meaning the center and the spread. Okay, so here's an example using the same data. So now we'll make different data classes. So we're only going to have 3 data classes. 6 and 7 are now going to be together. 8 and 9 will be together, and 10 and 11 will be together. So what that means is there's only going to be 3 rectangles now. One for each data class, so 6 to 7, 8 to 9, and 10 to 11. So now there's a lot more per data class. So I'm going to count by 5s, 5, 10, 15, 20, 25, 30. Because I'm combining stuff, so 6 and 7 will add up. So let's see, you don't have to scroll back up. I'll write it right here. So now there's going to be 18 data points in this data class, 6 to 7, because there were 11 and 7. So there were 7 and 6 and 11 and 7. It's a mouthful. So there's 18 total data points. So now I go all the way up to 18, something around there. And let's see, there's going to be 27 and 8 to 9. And in 10 to 11, there's going to be 9. If I add up the ones from 10 and the ones from 11. So right about there. Okay, so this histogram is not really that bad. It's not too bad. It's not as good as the other one, but it's not too bad because you can still sort of tell what the center is. You can still use it to estimate the median or the mean, but it shows much less spread than there actually is. It's also sort of more lopsided than the other one was. So we can make it even worse by choosing really bad frequency, like tick marks or whatever you want to call these things. So let's do an example like that. So this is the most common way to misrepresent data, I would say. So here's the same data, but now we'll count by 100 on the frequency side. So 100, 200, and 300. So now, since it's the same data, and it's out of 100 to the first tick mark, everything's going to roughly like look the same size, basically, because it's all just going to be, let me exaggerate it even more. Let's do 1,000. I'll change my mind, sorry. 1,000. So now everything looks like this, basically the same. Tiny, tiny rectangles. So now you can't see anything. Similarly, if you make your tick marks too small, then things will look giant, even though they're not that different. So you can't really see the true relationship. Or the shape. Or the spread. Okay, so that's a bad histogram. So I'll give you some histogram guidelines, but there's no like perfect rules, unfortunately, which is why people can make such different histograms for the same data. So here are the guidelines. So rectangles rectangle widths, they don't actually matter. They're all the same. And they must touch. So the fact that, let me use a better one. So the fact that this is including 2 numbers, this is also including 2 numbers, this is also including 2 numbers, doesn't affect the actual width of these rectangles. They should all just be the same no matter what. If you can draw very well, then they'll look exactly the same. Same thing up here. This one I accidentally made look sort of skinnier in the middle there, but they're all supposed to be the same exact width. It's not dependent on anything. Okay, that one is more of a rule than a guideline, actually. So let me just write part of what I just said down. So the width is not relevant to the data. It's just aesthetic, which I don't know how to spell. Aesthetic only. Of course, you shouldn't make everything super wide because then nobody could see things or make it too big. All right. So the next is that the data classes are what label the rectangles. And the frequency tick marks should be evenly spaced. Okay. So you'll get some more practice in the lecture problems drawing these things. What I want to talk about now is sort of analyzing histogram shape more. So the shape of the histogram can sort of tell us a lot of stuff. So we're mostly going to look at three main types. There are other types. So there are three main types of shape that we look at, that we study. But they're not the only types in the whole world. Okay, so the first is a symmetric histogram. So a symmetric histogram sort of sounds, it is exactly what it sounds like. So what it means is that there's sort of a bell, a symmetric bell, that you could fit over your data. So that's what it means. So the histogram is symmetric about the center. It doesn't have to be perfectly symmetric, just mostly symmetric. And so what this means is you can draw a bell over it pretty nicely. So the example we did earlier is symmetric. So let me go up there real quick and draw a bell over it. So even here, it's pretty symmetric. It doesn't look as nice as the other one, but it's mostly symmetric. It's not perfect. This one is much more symmetric. So you can draw a nice bell curve over it. Okay, so we'll see more examples too in the lecture problems. And there are properties about it that you should know. So there are, the idea is that there's going to be like a tail on both sides. That's what you call these portions of the histogram. But they're kind of small. They don't go very far. And then the best thing is that the mean and the median will roughly be the same. That's what this means. And that's always a good situation. If your mean and median are roughly the same, allows you to do a lot more cool things. So they'll both be right around here, wherever you can fit the bell curve. So up above in that other example, I won't scroll up again, but it's around 8. They're both around 8. Okay, skew left is the next type of histogram we'll look at. And that people get this one all mixed up because left and right sort of depends on what you think of first. So skew left histogram is one that has a tail on the left. So it still has this sort of bell curve, but only sort of moved over to the right. And so this is called skew left because tail on the left. That's how you have to remember it. So whichever side the tail is on, that's the side that it is skewed towards. So what's going on there? So let me draw a little mini example underneath it. What's going on there is typically you have a bunch of stuff sort of far away. So I'll just draw a little example like this. So it's usually something like this. You have most of your data crowded around one side, but then you have a couple of very far away things on the left. So some far away data on the left, and that's what creates this tail shape on the left. And then what's interesting to think about is what happens to the mean and the median. So as we've seen, the median will not get influenced by very far away data points. It'll still roughly be where the big crowd is, which is over here. But the mean will get influenced by very far away things. So in this situation, the mean will be a little bit lower than the median. It'll get pulled down. So that's what's going to happen when you have a histogram like this. So the mean will be to the left of the median. Or in very mathy terms, people like this symbol less than. Okay. So now maybe you can guess what the next histogram will be based on this name. It's going to be skew right. So it's nice. It's just the opposite of the previous one. So if you got the other one down, you can sort of get this one down pretty good. So now skew right means there's a tail on the right. And sort of the equal and opposite thing happens here, which is most of your data is crowded together over here somewhere. But then you have some far away stuff on the right side now. There could also be stuff in between. It doesn't have to have a big gap, but yeah. Okay, and that could have happened up there too. So now what's going on? Same idea. So most of the data is over here. But there's some far away to the right now. So what this is going to do is it's going to drag the mean up to the right. So the mean will be somewhere to the right because there's far away things to the right, which don't impact the median, but do impact the mean. So here, the mean is to the right of median, but in very mathy terms, what does that mean? Well, being to the right on a number line means you're bigger. So the mean is much bigger in this situation than the median. Whereas over here, the mean was to the left, so it was smaller than the median. So just to give you some sort of specific examples, so in something like this, you would have a bunch of data points, maybe, I don't know, around 50. So you have like 50, 51. I'm not going to do a whole bunch. But maybe you have a whole bunch of these guys. Something like that. Maybe that's your data. But then you also have a couple very far to the left, say just 2 and 3 maybe. And so what's going to happen there is the median will still be around this big grouping, but the mean will be much lower, probably around like the high 30s, low 40s, because of these two very far to the left numbers. So left on the number line means lower, so it's going to be a lower number, like 2 and 3. Over here, it's going to be more like, you have a bunch of numbers like this, sort of grouped around together. But then you have like suddenly just like a couple very big ones. And so now those two numbers are going to bring the mean up higher to the right, but the median will still be around this big group of numbers that are all around the same thing. Okay, so that's the generic idea. So the other thing that histograms can do, so that's sort of revealing how the mean and median are related, which has to do with the center of the data. But histograms can also reveal the spread. So basically, if you look at the shape of the histogram and it's symmetric, the bell can sort of be very skinny like this. And what would that be saying? That would be saying that there's very low spread. Most of the data is crowded around between here and here. So your histogram might look something like this. You just have tons of data all sort of stuck together. So your histogram would be very squished up. You could still have other things a little bit going out, but still very squished together, very low spread. So here the standard deviation would be a very low number. It would be small. But then you can also have your histogram be very wide. Actually, maybe I'll even draw it on the same graph so you can compare at the same time. So in red, or how about I do green for the graph? So you can also have a histogram that's much wider. So something like that. So now the histogram underneath that curve, still a bell curve, it's going to sort of look a lot more spread out. I'm just giving a intuitive understanding. So of course I'm not drawing a very good histogram, breaking all those rules I wrote. But those red rectangles are much more spread out. So there's high spread there for a wider bell curve or a wider histogram. So in such a situation, you would be able to tell that the standard deviation is big, or at least it would be bigger than this one because things are more spread out. Okay. So in the next lecture, we're going to talk about another way to represent data. And then we're going to go back to understanding spread using the median, which is what I said I was going to do in the previous lecture, but I lied. So that's actually in the next lecture. And this is the end of this one. Okay, so I will see you next time.